All right. So, good morning, everyone. Hi, gozaimasu. So, welcome to this session entitled Disaster Mitigation Monitoring and NRENs. My name is Franz De Leon. I am from the Philippines Department of Science and Technology, Advanced Science and Technology Institute. I also happen to co-chair the Disaster Mitigation Working Group. So a few months ago, just a little backstory about this session. There's an ongoing initiative in the Philippines called the COPFIL, Copernicus Philippines Action Initiative. It is a significant investment by the European Commission through the European Space Agency for the Philippines to host or become a mirror site for Copernicus data, and then for it to be a hub in the near future for the whole ASEAN region. So we thought that it connects perfectly well with what the Disaster Mitigation Working Group is doing. So we thought of having another, like a special session, just to share with you the updates of this current initiative. So the Disaster Mitigation Working Group and Open Sharing Data Working Group, in cooperation with the Philippine Space Agency, is organizing this session to share the current state and future for disaster monitoring and mitigation in the Asian region, and the role of NRENs in this important function. So this session will also feature the Copernicus program in the Philippines, as I mentioned, and how the ASEAN region and fairly the greater Asian region can benefit from this program. For this morning session, we hope to have our four speakers. We have Mr. Bayani Lara here, and then we have Denis Villorente of the Philippine Space Agency. We also have Dr. Casper Fibek, and of course, Andrew Howard. Good morning. Morning. So, for our first presenter, we have Mr. Bayani Lara. He's a network engineer of the Philippine Research, Education, and Government Information Network of the OST-AST. He's a science research specialist at our agency, has 15 years of experience leading the network operations group. He also takes care of routing infrastructure of the Philippine Open Internet Exchange, as well as the core network of the Philippine Government Broadband Network. He earned his degree in computer science at the University of the Philippines in Los Baños. So, ladies and gentlemen, please welcome Mr. Bayani Lara.
Thank you, sir. So, good morning. Lots of familiar faces in the room. So, I'll be talking about how a research network, how disaster mitigation and monitoring activities benefit from the infrastructure that is usually present in a research network. So, I was assuming maybe some people in the room might not be familiar with research networking, although I'm looking around, I think most of us are familiar with the work of NRENs. But for the benefit of some, or maybe our audio-video guys that are not familiar, it's different from your typical internet service provider. Okay. So typical research network, yes, it serves as an ISP, quote-unquote an ISP, for science, academic, and research. It's usually non-commercial, not for profit. Usually it's funded by different entities, especially usually the science ministries or the academic institutions within the country, to provide high-speed network links. So usually commercial providers, they charge you per MB or per gig of usage on the network. With science networks, they want you to use and use up all the bandwidth, of course, through science or research applications. And when it's fully saturated, well used, then ask for funding to bump up the pipes, the network links. On a technical level, research and education networks are engineered with low latency, low contention rates, and with sufficient headroom to accommodate those bursts of network traffic. Okay. So they are dedicated network service provider for academe, universities, research institutions, usually schools, hospitals. Some hospitals are heavy users of the research network through telemedicine. Before it was a limited application. Now we have Zoom and all of those video conferencing technologies. Libraries and museums are digitizing their content, and some are putting it over research networks. It thrives heavily on collaboration. Okay. So for the Philippines, we have the Philippine Research, Education, and Government Information Network. But right now, the Philippines has a young ministry called the Ministry of ICT or Department of ICT. So the G part, the government part, we are already turning it over to the ICT ministry. But the science network and the government network, at least in the Philippines, they're heavily interconnected. So for the science network, we now focus on uplinks, on links going out of the country. Then for the domestic connectivity part, we sort of slowed down on that and gave that work to the government network to connect government offices and all the other government schools. Okay. So PREGINET was proposed way back 1999. My former boss attended, I think, an AI3 group, then learned about the APAN group, attended here, saw it was useful for the Philippines, so he proposed a project which became PREGINET. Around 2000, 1 year after, he got small funding from the Ministry of Science and started the network. So it's been up and running for around 24, 25 years, more or less. Right now, we have 10 gig to Singapore, a 10 gig to Hong Kong, a 10 gig to Japan through our friends from Muffin here. We have a small 1 gig direct to mainland US, but the big one is 100 gig going to Guam, to US NRENs, and to Japanese NRENs, Indonesia NREN, and in the future, Malaysian NREN through the Arena Pack project of Professor Murai. So lots of collaborative activities over the network. This is more or less the timeline that PREGINET went through. Before 96 up to around late 2000, we were heavily dependent on commercial ISPs to connect point A to point B, to connect our router in ASTI to point B. Point B meaning a hospital, a school, maybe a government institution that needs satellite images or video conferencing. So we bought a lot from our partner commercial networks. But since the Philippines already has its Ministry of ICT, Department of ICT, the Philippines now lays its own fiber network for government and science use. This is the old, very old network. If you can see, 256, 512 kbps satellite link going to Japan through our friends in AI3 in wide in KO. We have E1s. Anybody here in the E1 era? 2 Mbps was already, quite a handful before. So this is the old network. We promoted a lot of IPv6 on that. Okay. And of course, the new network is much bigger in terms of bandwidth. Okay, so we had all this bandwidth and we needed to find applications to run and saturate the links so that, value for money proposition in terms of science funding. So we needed applications, and applications needed servers, needed hardware to push and pull packets over the network. So we thought of having before a science grid way back 2008. This was the sexy term. Now it's HPC, it's cloud. But before it was cluster computing if it's local, and grid computing if you tie these clusters together through a network. So we worked heavily with Taiwan, with Academia Sinica before, on grid computing. Of course, the common venue before was APAN. That is where we met. We met and did the e-science grid program, fairly successful. Then we were able to convince the university to also invest funds to also buy their own small cluster. Then we tied those two clusters together, our cluster and the University of the Philippines cluster, to have a Philippine cluster grid. Then we worked with the group of Eric Yen, Simon Lin to tie together different grids within the ASEAN region. Thus, we had the e-science grid project. So right now, I think nobody uses the cluster or the grid term. Right now, the common term is HPC, or on the commercial side, the cloud infrastructure. We also have Science Cloud and HPC facility that slowly grew and grew. Before, during this time, 2011, 2012, 2014, it was not heavily utilized because understanding on using the HPC, the engineers in the universities that needed the know-how to use this was quite limited. Okay, so we were marketing it a lot. But right now, during the present, actually, it's a good problem. We're heavily saturated. We are in need of severe upgrade on our HPC. And right now, several projects are in the pipeline funded by the Ministry of Science in the Philippines to bump up our HPC facility in ASTI. So we have these servers in typical buildings, you know, your brick and mortar data centers. But something interesting, we have an HPC facility in this container van. So it's a very cheap data center that we spent, I think, 10 million pesos. I'm not sure of the dollar figure. We can math. But it's an old um, container van that you put on the back of the truck. We had the contractor fix it, retrofit, you know, electricity and cooling. And it's actually working since, I think, that was there, I think, 2014, 2015. So quite a long time. It's still working. Okay, I got disconnected on Zoom. So can you help me? Okay. Yeah. Good. Yeah. Yeah. Maybe. Okay. Sorry, tech support. Um, can you help me get on the Wi-Fi? Okay, sorry for that. Thank you, ladies, for the tech support. Okay, so quite a cheap solution, since funding is usually a challenge within the science ministry. But this has been hosting critical data sets, including the rice genome data sets of the International Rice Research Institute based in the Philippines. I think our Muffin friends are very interested in that genomic database. Yeah, nagre-refresh. Wala eh. Okay. Hindi eh. Nagre-respond to pero yung sa kanila naka-freeze. Uh, is it possible to ask for your screen sharing is paused? Resume? Or resume? No? Ah, yeah. It's refreshing now. Yeah. So should we play again? Yeah, this one. We're getting a delay on the internet. It's quite heavy right now. So I won't go full screen. Sorry for that. Okay, so that's the HPC facility of ASTI, and right now this is the statistics. Uh, sorry, this is the statistics in terms of its processor, memory, and computing resources. Okay, then lots of local players on the left-hand side using the infrastructure. One notable user would be the Rice Research, an international organization, and PhilRice, Philippine Rice Research Institution. Okay, so lots of bandwidth, lots of computing. Now what in terms of within the context of our group, which is disaster risk mitigation? Um, The network hosts a server for Japan's Himawari satellite, Himawari 8, Himawari 9, and I think we're now on Himawari 10. This is the MOA signing with Japan and Philippine officials way back. And one of the heavy users would be the Weather Bureau of the Philippines called Pag-asa. Okay. So quite an old slide, but basically the Himawari data is pushed via JGN through the Muffin APAN link going to the Philippines, and it's also mirrored in Taiwan and in Thailand. Then we have a big subscription with a UK satellite company called Novasar. Then a project that came up from that satellite subscription is SAR-WISE, synthetic aperture radar. Then what do we do in that project? Ship detection is quite critical in the Philippines right now. There are several ships that is in our eastern and western side that sometimes turn off their AIS for ship identification. So we use this to monitor them. Agriculture, aquaculture structure mapping, forest mapping, those are some of the things that are asked of this project. So this is what the satellite, the Novastar 1 looks like. Object detection is one thing that we do with this project. You can go to this URL and check some of the articles there. Basically, Google CIASAT ASTI. They monitor the effects of earthquake. Then from the satellite images, they curate a report that will be given to local government units like this one, the LGU of Banguet and Langangilag in a province called Abra. They also also ask for flooding map data from them. This one was asked by the Cebu government, local government, in terms of flooding within their area. So recently, the project already ended, but our subscription with Novasar 1 still continues. So there will be other projects that will be done to process and curate this satellite image data. Okay. Another thing that we do in the Philippines is educate researchers and engineers on the use of satellite data and how to actually process them so that it's useful, since raw satellite images are quite difficult to use, at least for the informing the decision makers of the effects of whatever it is that they're looking at. So in partnership with the University of the Philippines and with the Philippine Space Agency, there was a TAIN funded project to do workshops and training on how to use and process satellite images. The project was called SICAP Plus, Space Infra Know-how and Applications Acceleration through Promotion and Training. So this was one of the workshops held recently. Then there was a recent ministerial meeting hosted by the Philippines through United Nations group, and the Science Ministry was able to showcase some of the DRM activities that ASTI does. So this is the current Science Minister of the Philippines in front of the ASTI booth with its DRM projects. So also all the data sets of these sensors at the back. Going back to our topic, they use the research network to store and forward those data sets. So the sensors that you see at the back, the one with the solar panels, it is this one. And there are around 2,000 plus automated weather stations, flood monitoring stations, and all of those things that are useful to DRM people to make a Philippine forecast in terms of disaster that is coming to the country, whether it's typhoon, flooding, earthquakes, so on and so forth. So this is the technology back end stored over the HPC, running over the research network that feeds data sets that is translated to reports going to the different local government units. So if you go to fieldSensors.asti.dos.gov.ph, you can see the distribution of the sensors there. And at the heart of the sensor is a locally made ASTI data logger. So everything is built within ASTI. And it has, I think, this is already, I think, its third iteration. Okay, so this can take in several sensors, can take in a Wi-Fi module, maybe a satellite module if it's deployed so far away. Right now, I think they're working on LoRa connectivity to test that. But basically, it gets a wireless network, and you can plug in several sensors there, then transmits back the parameters taken by the sensors to central office to ASTI. Another project that we have with the Japanese, this is a JICA-funded project, is to monitor lightning. Its aim is to observe the country's weather behavior through observation of rainfall and correlation with thunderstorm occurrences. Okay. So again, sensors that were deployed. Okay. So the project is called ULAT, or Understanding Lightning and Thunderstorms. For main outputs, deploy a lighting detection system, use Diwata and Himawari is the satellite images that we have. Use the satellite images to reconstruct a 3D model and correlate, the pictures from space to ground data, if there's any correlation there. Then to develop algorithms for better weather forecasting. And last, of course, to share the data with its users in real time. That's the important one, in real time. Okay, so not really your typical DRM activities, but the research network was used heavily during COVID. I consider that disaster, since our group is DRM, that was a global disaster. And the research network also hosted a lot of telemedicine activities over the 2-year lockdown period. Okay, so I think this project we are quite familiar, and Sir Denis will talk more on this, the next presenter. But bottom line, Europe will be hosting satellite images in Asia through Copernicus. And when that's done, I hope the group here can utilize heavily those satellite images that the Europeans took. So this is the science minister and the space minister of the Philippines with the different European officials launching the project. And PREGINET, the Philippine Research Network, will be playing host to that dataset. I think last of my slide, there was a recent science ministry event in the Philippines, and moving forward with all of those data sets, so we are now hosting a lot of raw and processed data within the research network. Now what? We usually process it, but not fast enough. So we're pushing towards AI to make processing of these raw data sets much faster, so it can be given to decision makers much faster. So the Science Ministry would be hosting a lot of AI projects. So the Science Minister launched the AR Virtual Hub. We are also looking at quantum computing. We have a large project on geospatial analytics to continue all of those telemetric projects of ASTI. Smart agriculture is on the table, and smart cities, something that ASTI will also look into. Okay, so I think that's it for my slide, and thank you.
All right, thank you, Mr. Bani Lara. Before we move on to DDG Denis Villorente's presentation, perhaps you might have some questions if you'd like. I can open the floor for some questions that you may have. All right, Andrew.
What is your total data holding across all of the satellite collections at the moment?
In terms of gig or tera?
Yeah.
I'm sorry, that is something I will have to get back. It's in the slide, but we don't have the Novasar data there. Yeah, I'll get back to you on that, but I don't have the exact amount.
Cool.
Okay.
All right, so I guess we can continue our discussions later, and you might have your own questions later on. So let's move on to the next presenter. The next presenter is the Deputy Director General for Space Operations, Infrastructure, and Industry of the Philippine Space Agency. Prior to assuming this role at PhilSA, DDG Denis Villorente served as the director of the DOST ASTI from 2003 to 2016. So some of you might be, of course, familiar with him. Following his tenure, he was appointed as an undersecretary for legacy systems and technical assistance at the Department of Information and Communications Technology. So among his numerous accomplishments during his directorship at ASTI, DDG Denis notably served as the original proponent of PREGINET, the country's first and only national research and education network. So without further ado, let me give you DDG Denis Villorente of the Philippine Space Agency. Sir Denis, please.
Yeah, thank you, Doc France. Good morning, everyone. Just checking if you can hear me.
Yes, DDG Denis, we can perfectly hear you.
Okay, perfect. Thank you. Thank you so much. First of all, my apologies for not being physically present. It's been a while since I've attended an APAN meeting. I think maybe my last meeting in APAN was back in 2017. So I'm very happy to be here, even if virtually. Thank you for the invitation to contribute to this workshop as well. Um, if I can have the slides, Bani. Bani, will you stream it from there or?
Just a moment, Sir Denis.
Sir, you can also test if you can share the slides.
Or
And
maybe can you
then,
do it for me?
okay, sir.
Okay,
Okay,
thank you.
sir.
Yeah, so again, good morning. My name is Denis Villorente. I'm with the Philippine Space Agency. This is a relatively new agency in the Philippine government, barely 5 years, well, 5 years old now. So in this talk, I will um, be presenting um, some of the work that we have started, and in fact, some of it we have inherited from the Department of Science and Technology that contribute to disaster management and mitigation here in the Philippines. And in the later part of the talk, how this might be relevant to the wider region here, and how we can leverage the infrastructure that's been constructed and being maintained and being expanded through the research and education networking community as represented by APAN. So next slide, please. So the outline of this presentation is basically just a quick introduction on the agency which I represent, the Philippine Space Agency, and then I'll go to the project which I think Bani Lara already introduced, which is the Copernicus Support Action, um, Capacity Support Action for the Philippines, and then how this might be relevant to the region, and also our need for infrastructure that is available from the APAN community. Um, on the Philippine Space Agency, as I mentioned, we were created by law about well, in 2019, through Republic Act 11363, or the Philippine Space Act, um, this law established the Philippine Space Policy, as well as the Philippine Space Council and the Philippine Space Agency. So PhilSA, or the Philippine Space Agency, is a central government agency here in the Philippines, addressing all national issues and activities in space science and technology applications, or what we call SSTA. We are an attached agency to the Office of the President. So unlike a number of space agencies in other countries, which are either attached to the Science and Technology Ministry or their economic ministry. In the Philippines, we are part of the Office of the President of the Philippines, and this is for purposes of policy and program coordination, as well as to ensure alignment in national policies and priorities. The agency is headed by a Director General with the rank of a Cabinet Secretary or a Minister. He also serves as the Presidential Advisor for Space Matters. As this slide shows, in the speech of the uh, President of the Philippines during the 77th UN General Assembly, um, he said that he wants to expand our presence, or the Philippines' presence, in outer space, and that is um, we start this by defining the norms of responsible behavior in outer space. So he's very much aware of the space program here in the country, as illustrated by his statements to the public. In the Philippine space policy, the framework for SSTA development stipulates these 6 key development areas as shown in this slide. And these are national security and development, hazard management and climate studies, so very relevant for the workshop this morning, space research and development, space education and awareness, space industry capacity building, and finally, international cooperation. In a country like the Philippines, as you can see, a space agency has a complex and varied role. So establishing and developing the space sector also involves significant effort, especially since we are a new and we want to grow this ecosystem, or the space ecosystem in Asia. Slide. Um, so many in the audience would be very familiar with space satellite technology, and in fact, this is already embedded in our daily lives. Just to illustrate, for instance, when we use a navigation application such as Google Maps, that we are already interacting with technologies from satellites. So, for instance, the maps that we use are generated from images taken from satellites, such as the Earth observation satellites. Um, the data to determine our position are provided from satellites that orbit the Earth, no? Position navigation and timing satellites, what are called GNSS, global navigation satellites, and data that you have communication satellites that form part of the global communications infrastructure, including the internet, and it's quite critical for sending and receiving all of this data. And then, of course, you have weather satellites that provide data used for forecasting the weather as well as climate. So you have different types of satellites orbiting the Earth, and this is already embedded in our daily lives. So next slide. I'll be talking more about the first one, which is Earth observation satellites and the data um, that they generate, and we need to receive, store, process, archive, and so on. So in the Philippine Space Agency, we use this framework called the Space Data Value Chain. At the end of this chain, what we're really after are socioeconomic value and benefits realized. But before we are able to realize the socioeconomic value and benefits, we need these five components. What you see here as um, from 1 to 5, we need all of these components to be present, working in that in this value chain. And so all of the activities and plans that we have in the Philippine Space Agency focus on looking at all of these components and trying to see, um, making sure that we have them. We identify the gaps, we strengthen these components, um, and so that we realize the value at the end. Um, At also, what we have also introduced a feedback loop here because um, we also need this feedback on the outcomes and impacts properly measured so that this can guide further investments in each of the components in this value chain. And then underlying that, you have the support components, including research and development, education, and capacity building to make sure that you have a constant stream of people that enter into this space ecosystem that we're trying to build. We need public support, so we do public outreach, and of course, very important, policy planning and international cooperation. So what are these components in the space data value chain? One, um, you need the upstream infrastructure, or the satellites that are orbiting around the Earth, and infrastructure to bring them up there, so, such as rockets, of course. Um, These satellites have payloads. So in the case of Earth observation satellites, you have sensors to generate imageries or to measure parameters and data that are relevant to specific use cases. And then this data, you need them to be suitably accessible in the right formats as well, that you can process and ingest. Um, and then, of course, you need ground infrastructure so that you can download this data and host them and process them and archive them. And then fourth, all of this data will be useless unless you have the capacity to analyze. And from that analysis, generate insights. These insights would be useful um, not just to the space agency, but everyone in your ecosystem, other government agencies, including from agriculture, environment, natural resources, economy, finance, trade and industry, and of course the private sector. Um, so the last component, of course, is even if you have products from all of these space data, from your analysis and the insights generated, unless these are acted upon by user organizations who have the impetus to use them and to act on them, then that's the only time that you can actually create value and benefit from all of these efforts. So these components need to be working together. And when we look at the space ecosystem, um, we're mindful of all of this, and we need to strengthen. So next slide, please. I'll go to some of the components in more detail. So I mentioned that we need access to data. Um, in the case of the Philippines, we have our own satellites. So they're in this slide, what we call sovereign satellites. Um, we have Diwata 2 still in orbit. We also sent up cube satellites. In the case of the Philippines, we call them the Maya series. So we've sent up Mayas 1, 2, 3, 4, 5, and 6. And then the Diwata series of satellites, Diwata 1 and 2. These are 50-kilogram satellites with cameras, different cameras as payloads. And then I think also mentioned in the presentation of Pani, we have access to synthetic aperture radar satellite owned by the UK called Novasar 1. And then we heavily leverage on open data from satellites owned and operated by the European Space Agency, the Sentinel satellites, and then from the US, operated by NASA and NOAA. And then we also pay subscription to access commercial satellites, some of them shown here. And then finally, we are part of the International Disaster Charter, which allows the Philippines to activate and get images, also contribute images from our satellites during disasters. So these are the disaster charter activated satellites that we sometimes get data and images during times of disasters in the country. And then we also respond to charter activation requests coming from partners under this international charter. Next slide. So to date, we have shown here generated, well, this is as of 2022, 62, more than 62,000 maps produced from images that we've processed. But together with that, we've also provided more than 140 per thousand person hours of training. These are for people in the agencies that we've provided these maps to, because we need to capacitate them on how they can interpret the maps that are provided to them. You also show here a space data dashboard. This is a platform designed to provide space data access for institutions and citizens if they want to look at the catalog available from PhilSat. Next slide. We have this effort we call Data Analytics Technologies and Operation Services for Space Data, or DATOS. It actually provides it's a network of space data users and contributors, so that we can operationalize tools and systems for the stakeholders, so that they get access to this data, and we provide the context of how this data can be turned into information useful for their specific use cases. Next slide. So the next set of slides just shows you some examples of the use of these satellite images for disaster risk reduction. So this one is an oil spill map we generated last year when we had an oil spill incident because of the sinking of a marine tanker when after the passage of a typhoon. No? This in particular, this is in Manila Bay, very busy waterway in the Philippines, national capital region, and so quite urgent mapping effort, trying also to predict where this spill, this oil will be going. We want to prepare the community in case this actually reaches the shoreline. So in this case, we used images from sovereign satellites, our own satellite, from open source satellite, including the European Sentinel satellites, and from our commercial satellite subscription, as well as the activation of the disaster charter, where we had images from the Canadian RadarSat-2 satellite. Next slide. This is monitoring of forest fires in the mountain. This was early this year, where we use satellite images to monitor the extent of burnt areas caused by grass fires in the northern part of the country. We have some detail on this map as shown here. So these maps we provide to our responders on the ground so that they can plan their operation, how to respond to this grass fire. No? Next slide. And then you have the flood impact mapping. We have we process the satellite images to show the extent of the flooding during heavy rainfall or during typhoon incidents. And then we generate information as well on the impact of this to infrastructure and affected population using data from the statistics agency. Next slide. Landslide monitoring. So here we provide a product showing the landslide area, but then overlaid on top of that is an image on the location of structures on or close to that affected area, so that this can be used by the responders on the ground to direct them to where to look for possible survivors. So when you're actually there on the landslide affected area, it's difficult to appreciate the area before the landslide, and difficult to see or determine where you might have a high probability of pulling out survivors. So a map such as this is very useful for them to guide and direct their operation. Next slide. So here we just pulled this from the social media page of the local disaster response unit in that area, and it shows them um, discussing their operation and the use of the map that we provided to them in particular is you can see here how that is useful to them. Yeah, next slide. So let me move on. So the next few slides will talk about this project. I think this has uh, well a history already. I think the discussion for this project started with the Department of Science and Technology even before the establishment of the Philippine Space Agency. But now we're in the middle of implementing this, um, and um, so we're very happy to share some update on this. It's called the National Copernicus Capacity Support Action Program for the Philippines, or CAPFIL for short. And in the words of Commissioner Ursula von der Leyen, the president of the president of the European Commission, she said in her visit here in Manila, Philippines, we are currently setting up a so-called Copernicus data mirror site within the Philippine Space Agency. And we have just signed an agreement to boost the flow of Earth observation data between us. This is very important for early warning, for example, for extreme weather phenomenon, and to improve climate resilience. This is a first in space cooperation in Asia. Um, so essentially, Europe owns and operates a number of satellites they call the Sentinel series satellites. And all of the data generated from these satellites are provided as open data, um, accessible from um, um, servers in Europe, no? Because all of the data is downloaded to Europe. There are, I think, in the case of Asia, there's one mirror set up in Australia. I know we have our friends from Australia present in the audience. They'll be able to tell you more about what they're doing. But this particular initiative is supported in the Philippines. It's supported by the European Commission, and it's the only one we're doing here in Asia right now. And there's a second a similar one, a second initiative that they're also doing, in this case in South America. Um, so this project is being implemented in partnership between the Department of Science and Technology here in the Philippines and the Philippine Space Agency, and the European Space Agency, um, together with the European Union delegation here in the Philippines. In the map here, you show it shows the well. This is actually planned. It's a delineation of I guess, the Southeast Asia region, um, and the what is being set up here, the data mirror that is mentioned, will actually host data, um, initially just covering the Philippine territory. So still limited initially to just the Philippines, um, but um, we're we're um, um, we're going out and saying that we are very interested in how this data mirror could possibly um, be expanded to cover the area that this delineated in red in this slide here. Um, so the Southeast Asia region. Now, what's the benefit? Okay, so right now we're accessing Sentinel data out of Europe, or in the case of Asia, maybe from Australia, from their data mirror. Um, and so there's a delay in that access. And so for some use cases, that delay might be uh, not really significant, but in other use cases, including for use in disaster response, that delay might be significant. And so having that data available for processing closer to our region would be very beneficial. And that's the idea for why the European Commission is supporting the establishment of this data mirror here in the Philippines. It's because, well, in the case of the Philippines, we are one of the top um, countries exposed to disasters, including because, well, disasters due to climate change. Um, Now, below, so this data, unless you're able to process, will not be very useful. So below, um, we show here three pilot services that are part of this project and being co-developed between users here in the Philippines and counterparts in Europe. So what are these pilot services? Um, you see them here. So one is on ground motion monitoring, whether that motion is you know sinking of the ground or upswelling for whatever reason. No. Um, Second one is actually three services or mapping services: land cover and land use change, crop mapping, and then forest mapping. Um, and the idea for this is, well, in the case of the Philippines right now, we generate our land cover maps every 5 years. And by using data available from the Sentinel satellites, as well as artificial tools, including artificial intelligence and machine learning, um, we intend to increase the frequency of generating these land cover maps, um, forest maps, and crop maps from right now 5 years to 1 year. And in the case of crop maps, seasonal, depending on the crop. Um, and then a third one is benthic habitat monitoring. So determining bathymetry of areas close to shore, and then mapping corals, seagrass, and other benthic habitats. No, very important for food security in the case of the Philippines, of course, other uses. Next slide. Yeah, so some more detail. So as I mentioned, this is being done uh, um, as a co-development using co-development methodology, agile. So um, we hope that from this pilot projects, the next stage, of course, here will be to expand this to cover the whole country. Uh, and then our perhaps ambition is where some of these services might be relevant to um, neighboring countries when COPFIL expands to cover other areas outside of the Philippines, including in the region, then the methodologies developed from these pilot services might be um, adopted for use in these other territories. So next slide. I think I mentioned this, so just some more detail on, in this case, the land cover maps, showing the resolutions that are planned and the frequency of update. Next slide. Okay. Well, for the data mirror that is being established in the Philippines, we launched it late last year. There will be um, online presence for the platform. And right now, the infrastructure is being set up and will be made available once everything is stabilized um, within the first half of this year. Next slide. Together with those two components, the data mirror, establishing the data mirror, and working on the 3 pilot services and then expanding them to cover the country. A third component is on capacity building and stakeholder engagement. So this is more targeting end users for all of this information and processed data coming from local government units and national agencies, and then the private sector. Um, Next slide. And we also conduct awareness raising. Next slide. So I think this is my, well, a second to the last slide, I think. So why are we um, presenting this? So as you can see, there might, this would be relevant, what we're doing under COPFIL would be relevant in, um, you know, other countries, those that you represent. So we're right now talking about potential expansion of the COPFIL infrastructure to support regional scope. Um, the European Commission will be making some announcements, but I think they're looking at expanding this initially to 2 other countries in Southeast Asia, perhaps not at the national scale, initially at certain smaller areas within 2 countries here in Southeast Asia. And the other one is, of course, as you can probably imagine, this data mirror will not be very useful unless we have good connectivity infrastructure um, to the original source, which is in Europe. And so we heavily leverage use of the national and global research and education networking infrastructure. And that's why we're here in APAN, because this is where the people that are operating and building this networking infrastructure are. And we need your support um, so that we can create operational use cases important for our country as well as the region. Um, I think the next one, my last slide, for more information on the applications here in the Philippines of all of these satellite data, we have this online ebook, the ebook uh, called Our Place in Space. You can just Google it to see um, more details on where we are applying this space data. So I think that's it for my presentation. Thank you very much, and I um, welcome any questions and discussion to follow. Thank you.
All right, let's give him a round of applause, please. Thank you. So that was a very comprehensive presentation from DDG Denis, as well as a bit of a snapshot of what they've been doing in the past couple of years, and the next big thing, which is Copernicus, which will not only benefit the Philippines, but the larger ASEAN region. All right, so we still have a few minutes, if you'd like, for a few questions for DDG Denis. Andrew, please.
Hi, Dennis. Andrew here from NCI. We have posted the new interface code up to Git. So if you search for OzCop Hub on Git, that'll provide you the latest version of GSS, which is the newer standard that the Copernicus program will be using for data download. Also, please feel free to have any of your people reach out. We're currently storing around 5 petabytes of Copernicus data alone. And we will also be expanding our region of interest. Well, we have expanded our region of interest to now cover all of Antarctica, as well as the overlap with the Philippines. So I'm hoping that that will give you the front-end capability to actually be able to use a lot more of the Copernicus data really easily.
Thanks, Howard. Thanks, Andrew. Sorry. Yeah, we'll get the details from you. We'll reach out. Thank you.
Okay. Any other question or clarification? None so far. Anyway, so before we move on to a tea or coffee break, I guess let's have a group picture because we have a good sizable attendance here in this room. So please.
Can everybody go to the front so we can have a picture?
All right, so a bit of an exercise this morning. Oh yeah, if we could change the one projected on the slide. Thank you, DDG Dennis, and see you very soon.
Thank you. Bye.